Hello, everybody. My name is Sajad, and it's my pleasure today to talk about the energy storage solutions by Epever. So, I believe this is a critical aspect of energy storage nowadays, and it, it's not only about the devices, but it's about the way that we live, the way that we store energy, and the way that we contribute to a sustainable environment. And there are lots of opportunities for us to discover as individuals, as companies, as industry players. So we are very excited today to explore a little bit more about EPA's offering in this field and see what kind of solutions are provided and what are the possibilities here. This is a quick look at what we will cover in this session today. We'll begin with a brief introduction. We will start with the global need for energy storage to understand the role of such systems better. Then we will go into the overview of EPR's energy storage systems, the different available categories, and the product ranges that we offer. We will have a look at applications and we will try to associate some real world applications for each series that we offer. Monitoring and control, of course, is an essential part of every system. So this also applies to the ESS. We will cover the possibilities here, and we will have a Q&A session for your questions live. So, to understand why energy storage matters today, we need to begin with the real world challenges. Not in theory, indeed, but in the systems we work with every day. So, there is rising demand for energy that is both clean and stable. And it's not just about going green again, it's about meeting the demand from homes, vehicles, industries, and doing it without interruption. And then the shift towards the decentralized, intelligent energy systems. The idea of big central power plants serving everyone, that model is no longer enough. We need systems that can work locally, to store energy on site, and respond faster whenever it's needed. And then the third is the challenges we all see more and more, the grid instability and power shortages. And this isn't just happening in developing world. Even in advanced regions now, we see blackouts, we see voltage drops, and renewable mismatch problems. And these issues are only growing. So before we go to our solutions, probably we'll have a look at EPEver's journey in providing answers for these issues or these problems. Many of you might already be working with us for over a decade or even longer, and you've seen us grow in many cases. We started simply from charge controllers as our first line of products, and we work hard to make those products reliable, affordable. But as the energy systems change, the needs around us also change, so we can hear more about the voice of the customer, the requirements of the customers, and we try to do appropriate research and development. So if you look into the portfolio of past 2 years, what has been released by EPA, you'll see how aggressive the R&D market is, and we have completely new series of products that answers the VOC requirements. That we hear the voice of the customer and we try to manufacture quality products that are trusted in more than 100 countries. So in this webinar, we're going to see the relatively new launched products from EPA. So first things first, what is an energy storage system? So simply put, it's a system that stores electrical energy for later use. So this helps to bridge the gap in power availability. So it makes it a reliable solution, whether you are on grid, whether you are off grid, or you're using hybrid system. And there are different configurations, and we'll get to those shortly. But the core function is the same, to deliver stable, predictable, and controlled power. So what exactly ESS does first is the backup. When the grid fails or fluctuates, the system keeps essential loads running. If you're using solar or wind, ESS can capture excess energy and let you use it later. And if you can start small all the time and use it as your needs grow. You can add batteries, you can add capacity to the system, so it's quite scalable and it provides the scalability in your system and offering lots of cost saving opportunities. We will have a look of the return of investment for such systems, ESS systems, and see what it means in terms of costs and savings. And finally, ESS contributes to a sustainable world by reducing emissions, by reducing the fuel dependency in a larger scale for the society. Well, when we look into the ESS systems, the first category is basic DIY systems. So you are very well familiar with the components. We have the PV panel, we have the surge resistors and the protections in place. A key component is a charge controller, which makes sure to harvest the most possible from the PV array and charge it into the batteries via the C distributors, the fuses, via the bus bars, and etc. And then the energy stored in the batteries is converted to AC via this critical element, which is called an inverter, and of course there are means for communication. So this is a very basic DIY ESS, a custom-made system, but actually we are stepping into what we call the advanced commercial ESS systems. These are typically using grid-tied, industrial, and hybrid systems, and they're usually more complex in comparison with what we just saw, in comparison with DIY systems. They are designed to handle larger loads, multiple energy sources, and much more control. And you will find a slightly different components. Actually, the functionalities are similar or the same, but they're named differently and they act differently. So you'll find battery modules, the power conversion systems, which is a bidirectional AC to DC conversion system. You'll find DC to DC converters, and we will explore soon what it means. There are switches to switch between the sources available. We have the battery management systems for safety and control, and more control over how the energy is consumed. And then, of course, some software around and some SCADA systems. So we are moving to a new area, which is called the commercial ESS components, and they are becoming more and more common in the world. So let's say they are entering the residential world quite quick. But we have two types of systems here. Like we have AC coupled systems and we have DC coupled systems. So let's explore each of those. So for an AC coupled energy storage system, the solar energy generated by the panel is first converted into AC by a dedicated PV inverter or on-grid or off-grid inverter, what it is. And that AC power then either supplies your active loads directly or flows through a power conversion unit, often called a PCS or inverter charger, to charge the batteries. What's important here is the use of shared AC bus, as you can see. All components, the grid, generator, loads, and battery storage are connected and are talking to this AC level provided in this AC coupled systems. So this architecture is particularly useful for retrofits, let's say. For instance, if you have already installed solar panels with a grid-tied inverter, with a microinverter at your house, and you now want to add a storage, this is the solution to go. In that case, you don't need to touch the DC side of the system at all and just step into the existing AC infrastructure, and the new components will be blended in the system. And that's one of the biggest strengths of AC coupled systems. And you can scale, you can upgrade or replace components with minimal rewiring. And it's also excellent for hybrid setups, where you actually might be switching between grid supply and solar input or the generator backup. There's a bit of issue here, not critical, but it's worth mentioning that you'll encounter some efficiency losses here because the power gets converted multiple times from DC to AC and then from AC back to DC and for the storage and this includes some conversion losses. But in exchange, you will get flexibility, of course, your system level independence, and a much easier path to expand or integrate into a commercial or multi-source systems that you have. So when the goal is to add a storage to an existing site or work with grid parallel designs, AC coupled systems are the solutions to go. And on the other side, we have the DC coupled systems, and it actually fundamentally differs from AC based systems. And let's see why it is. In a DC coupled system, both your solar panels and your battery bank connect directly on the DC side. So this is a DC bus for us. Whether it's low voltage or high voltage side, we have a DC bus here depending on the system. And there is no early conversion to AC. Instead, energy flows straight from the PV array through an MPPT charge controller and into the battery with a little energy loss along this DC to DC conversion, but it's negligible, let's say. So we have fewer components in pass, fewer conversion, and overall higher round and higher efficiency of the conversion system. And there's also another big advantage or strengths for these systems: energy capture under low light conditions. So normally with AC systems, you need a minimum threshold of energy available before you can convert it or before actually inverters kick in. But for the DC systems, because the MPPT is there, you can start with very low systems. So all in all, in systems that every watt captured needs to be a watt kept, this is the system to go, and we can go for such systems. So indeed, the AC coupling works better for upgrades, and DC coupling, of course, for new systems, but also for upgrades of the existing systems. And DC coupling is still the go-to solution when you're designing a purpose-built system from scratch. And it's of course preferred in clean stage microgrids, telecom, backup systems, and remote island setups. So we will have a quick look now at the ESS solutions offered by Epever. We have structured the lineup into 6 categories, and these categories actually serve different purpose. We have mobile power, residential backup, grid connected systems. And we will have a quick look at what are our offerings as Epever in regards to ECS systems. So the first 3 categories here. First, we have the portable power stations. These are self-contained plug-and-play units. They are designed for mobile work, outdoor tasks, for emergency power, and you'll find all the common outputs like USB, AC output, and DC output. And the goal is simple. We need a light wave system, which is practical, which is easy to use, which is portable, and you can see them in remote job sites, off-grid locations, or simply where a reliable backup is needed. And we offer the HDS and ADZ families of these products. We'll discover it a little more. And then we have also the residential backup systems. These are also complete systems with an inverter and a battery integrated into a single unit. And they're ideal for houses, small shops, or any place where grid interruptions are frequent. And everything is pre-matched internally, so installation is just simple. It's a plug-and-play unit, and you can start that. So we have the HPS AHL and AL series available. We will discover more about them. And then we have the all-in-one modular ESS for stackable rack-mounted systems. And these systems also combine everything: inverter, MPPT controller, battery bank, BMS, everything built into a rack mount or a stack mount format, and they're commonly used in commercial settings, let's say. So we have the ROH, HP20, and FP20 series offered by Epever here. And these are the second three categories of the products we offer. We have the energy storage inverter platforms, and these are standalone inverter chargers. They are not, bundled like what we see. They're not complete systems. They're just inverter chargers, but they can act as a core of a custom ESS system. That's why they are here introduced in this family. It means that if you want to design a system from individual components, or if you are integrating with batteries from another vendor, these devices give you the control and performance needed. And they support both lithium, lead acid chemistries, and they're widely used in many applications: telecom, cabins, and even small CNI setups. So we offer MP, UCP, KRP, HP, EHT, QI, and ELS series, and each have their own functionality. We'll introduce why we have so many models available. And of course, we have high capacity industrial systems now available. This is where things scale up dramatically. We are looking into almost 105 kilowatt of power here. They're typically including a power conversion system, the batteries, the energy management system, and they're deployed in factories, logistics centers, and commercial buildings. Um, the power provided can range up to 215 kilowatt hours, and this makes it suitable for many applications. And finally, we have the batteries, the lithium batteries. EPR now offers several series of lithium batteries, and all are based on live PO4 chemistry and designed for integration into ESS systems or whatever system that you have. We have a wide range of rack-mounted, wall-mounted ABS metal enclosure from 12.8 to 120, 102.4 volts, and we will discover more about the batteries in the coming sessions. So let's explore each series with a bit of more details. Portable power stations. So this HDS series are small, simple, and solar-ready systems for powering devices like lights, cameras, phones, or a router, specifically in indoor use or quick fill deployment. And it includes the MPPT charging, USB outputs, and supports LiFePO4 or lithium nickel cadmium batteries. And it goes up to around 600 watt hours. But the ATZ series is a much more powerful unit. It delivers up to 3.6K, as you can see, of rated power. It can surge up to 5.4 kilowatt, and you get the 230 volt AC pure sine wave, multiple USBs and DC systems, and it charges from solar, car, or AC. So this is a 230 volt AC product. So self-driving camping, aerial photography, outdoor work, and home power backup systems are kind of applications that are associated with these two products offered. And then we have the HPS AHL and AL series, of course. The HPS AHL models are built around the LiFePO4 battery pack and come with 2.5 kilowatt of power options. You can find a pure sine wave AC output, a built-in MPPT controller, and a charger, and it charges via solar, utility, and generators. It comes with the LCT for the display. It comes with DC outputs, USB-C ports, fast charging ports, And it's a plug and play solution for homes, small cities, and off grid systems. And HPS AL series, on the other hand, use lead acid batteries, quite similar to AHL series, but based on lead acid batteries, have the common configurations that uh, the AHL series have it. And it really depends on what type of a storage solution you want to go for. You will be powering the household appliances, power tools, small industrial machines, audio, and AV equipment. So if you need this simple, safe, and reliable backup, these are the products. So then we have the all-in-one modular ESS systems. And these modular systems are designed specifically for larger capacity scenarios like schools, clinics, and standalone buildings in off-grid or V-grid locations. So we have the HP20 and FP20 series. They are of course similar to each other. You know, they both use a cabinet-based stack of lithium batteries and a 5.5 kilowatt inverter with up to 6 battery modules per system of capability. But their key difference is the physical design, installation module, and space adaptability. So HP20 series are wall-mounted systems, and the FP20 is the floor-mounted system, and you can choose based on your space requirements and installation requirements. So 5.5 kilowatt inverter, up to 6 stackable batteries, dual MPPT solar inputs, grid support, generator support, and solar support, remote monitoring with Wi-Fi and Bluetooth. So it's a quite versatile system, let's say. And as we introduced, now we are looking into the energy storage inverter platforms. So again, these are not full ESS systems. They don't include batteries, but they are a critical part of power architecture. So why do we offer so many series? Because each one serves a specific scenario, from grid-tied homes to fully off-grid remote systems. So for the MP series, this is a split phase, low frequency hybrid inverter available in 3 and 5 kilowatt versions, and it's supporting both 120 and 240 volts AC. And it's ideal for North America and many other regions with robust stability, power feedback, and utility generator compatibility. And we have the UCP KRP series. These are the high capacity off-grid solutions going up to 5.5 kilowatt. Um, and then they're modular, making this product suitable for commercial, education, or healthcare systems. Then we have the HP systems coming in for 4 variants from 20 amps to 65 amps and ranging up to 5.5 kilowatt. So they support both 24 volt and 48 volt batteries, multiple MPPT inputs, and vary by enclosure type, noise profile, and system protection level. We have EHT series. This is our most advanced split phase on-grid hybrid line from 6 kilowatt to 12 kilowatt, and it makes a perfect product for 120 and to 40 volt home systems. So you get 3 to 4 MPPTs, up to 18 kilowatt of PV input, and a seamless switchover. QI series is actually a smaller and compact system, just 1 kilowatt system, and it's perfect for remote shelters, surveillance equipment, and basically low load cabins. And finally, we have the ELS series here. This is the grid-tied hybrid inverter for residential rooftops. It is available in 3 kilowatts and 6 kilowatt versions, and it's optimized for homes that want PV self-consumption plus backup and easy indoor installation. Actually covering diverse range of requirement for different applications with these inverter platforms. We are looking at the high capacity industrial systems. This is the heavy duty end of our lineup. And just to clarify, this is a complete energy storage system. The CS215 series, they come fully integrated with live PO4 battery modules, power electronics, BMS, thermal protection, all inside this cabinet. So it's actually a plug-and-play system, which delivers 105 kilowatts of power, as you can see here, and 215 kilowatt hours of energy. And it's built for three-phase, four-wire systems and works across 240, 400 volt systems, 50 or 60 hertz. So it's suitable for Europe, Australia, or the US with a step-down transformer indeed. So just to give a sense of a scale about the 215 kilowatt hours, this can actually power a typical household for about a week or run a commercial telecom station overnight. And that's serious backup for critical infrastructure. And it uses high cycle battery stacks rated for over 8,000 cycles. And of course, it's a matter of environmental effects, the use profile, the depths of discharge, but it can go up to even further cycles. It includes fire suppression, industrial grade communications like Modbus, and passive cooling, so it means lower noise and no moving parts. A bidirectional 105 kilowatt power control system is included with a 5 kilowatt MPPT system for solar inputs. It's IP54 on the outside and IP67 for the battery cells, and weighs around 2.5 tons. And this platform is best for charging and swapping stations, industrial parks, commercial energy hubs, which are looking for integrated storage without the need for external enclosure. So we will cover these series in more detail during a separate webinar soon. And the last but not the least category of the products we offer are our batteries. So Epever has entered into the battery manufacturing world due to the increased global demand. We offer lithium batteries in different scales. All our packs include live PO4 chemistries because they are safe, they're stable, they come with higher lifespan, let's say from 2000 to 6000 cycles, depending on again consumption level, environmental factors, temperature, depths of discharge, and etc. And we are using these in places like boats, streetlights, RVs, home systems, home backup systems, residential, commercial systems. So it's a full range of live PO4 or lithium iron phosphate batteries. They come with small capacity packs, 12.8 units, compact, rocked, for things like sensor nodes, lighting, or portable units. We have the ABS or metal cased modules, more durable, low voltage, use in off-grid RV or outdoor cabinets. And for structure setups, we have the rack mounted systems. And these go to from 52 amp hours to over 200 amp hours and are perfect for telecommunication, data center, and modular ESS racks, shall we say. Then we offer also the wall-mounted modules. As you can see, we have quite a significant capability also here, up to 314 amp hours with LED and LCD indicators. And again, we have higher capacity ESS and solid state packs. These are floor standing high capacity units. These are stackable, stable, and ready for hybrid, CNI, or commercial and industrial systems. And you can think of a backup for a site or solid state packs that scales with the loads. And as a quick word on protection, some product lines of batteries have built-in smart BMS system. This means we have protection against overvoltage, undervoltage, over temperature, short circuit, and current spikes And more importantly, we have the cell balancing, which is quite critical for lithium packs because you can easily overstress a single pack. And having a look at the global certifications, CE, IEC, ROHS, MSDS, UN 38.3, and more coming soon, which indicates indeed a safe product from Epever to deploy. So we will have a dedicated battery webinar in the coming future so that we will dive a little bit deeper into the details of the batteries. And of course, monitoring and control. So every ESS system needs an interface to read the data and interact with it. So you get live performance data, power generation, grid exchange, battery SOC, and more. And this is not just for graphs, it's for diagnosing. So if you want to diagnose the problems fast and optimize energy use in real time, you need a means for communication and controlling the system, and that's what monitoring and control about. So for remote access, you can use phone, you can use your tablet, your browser, you can check the system status and history, you can push firmware updates, you can receive smart alerts from the system itself. You can set the configurations of the different components of your system, like your batteries and the BMS functionality. And for local operations, you've got the LCDs on most of the products. For deeper insight, we have cloud dashboards, which give the possibility for analytics and the visual trends from the cloud backup systems. And whether you are a technician or a facility manager, everyone gets the control and a view over the system and its components. Of course, each product has its own different monitoring specifications, but this is in general what we offer in our products. So we support also the open communication protocols, RS-45, Modbus, CAN. So this platform plugs into most energy systems, inverters, BMS units, smart meters, and charge controllers. And of course, security is also important. We have encrypted comms, you have password locks, you have custom alerts for temperature, voltage, SOC, and more. So all in all, it provides you the control over your system, your energy, basically anywhere and anytime that you are. So given all those functionalities and product series, we can conclude that we can cover different area of applications like off-grid, on-grid residences, telecom base stations, agricultural systems, EV charging hubs, and commercial backup systems in a nutshell. So to conclude this webinar, we will have a look at the decision-making drivers, the financial performance and return on investment. So energy storage systems represent a significant capital investment, covering batteries, inverters, controllers, and electrical installations. And this is your capital investment, but you also have the operational expenses for maintenance, monitoring, and sometimes you need to replace your batteries. But these are all costs, and they are not isolated costs because they are valued against measurable revenue and saving streams. So if you look at the time of use, this means that we can store the energy where electricity rates are low, usually midday or overnight, and use or export it during peak rate windows. And the margin becomes a direct saving or even a revenue stream. And then there is a peak shaving capability. By smoothing out high demand spikes, ESS helps avoid heavy demand charges from the grid, which is a critical factor for commercial and industrial facilities. We also cut down the fuel use. Anywhere that diesel or generators were used, ESS power can dramatically reduce or eliminate the costs. And of course, self-consumption. When you use more of your PV energy, you are avoiding grid prices and feed-in losses. So now, what determines how quickly the system pays off? It depends on many factors. But first, let's have a look at this number. There are studies around the return of investment for ESS systems. For example, for Australia, for a commercial PV plus energy storage system project, there is a value of 5.6 years of ROI. In the UK, for a residential battery system, it can go lower to 4.8 years. And on the industrial systems, indeed, we can go lower and lower because we can use, you know, incentive frameworks from the government, and we can go as lower as 4 years in some regions in the world. But of course, in markets with flat pricing and no policy support, of course, 8 to 10 years is more typical nowadays. So, how to accelerate your return of investment? It's a good question that we receive quite often. If you are operating in regions with violate electricity pricing or time of use tariffs, you are already working in a favorable economic environment. So these markets reward energy shifting, and energy storage is the ideal tool for that. Next, if you look at your load profile, and if your site has periodic, predictable daytime demand, you can actually program your system in a way that all can be controlled to match solar production or off-peak hours. So it's also a culture of consumption and programming the system for regular loads that can determine how quick your return of investment is. And now a growing trend is the virtual power plants. So many utilities and aggregators now allow the ESS systems, ESS owners, to participate in demand response programs. So you get paid not just for what you use, but for how and when you use it. And that turns your ESS into an income generating asset. But maximizing ROI is not just about reducing or controlling the usage. You need to be wise on choosing the system components. You need to go for life pure batteries because of the noun stability and longer life cycles. You need to opt for warranty-backed systems all the time because if you have to replace your battery and the warranty is not there, it's a major cost component for all the systems. It's a major OPEX component, and it will prolong the ROI procedure. And of course, one needs to use the monitoring tools wisely. We need to monitor the system for any sort of problems, for any issues like over temperatures or any faults in the system. And we need to observe the system to increase the sustainability of the system so that it can last long and it can pay off the initial cost that comes with. So with that, I think we can conclude this webinar session.